these shoes, Midge. They're perfect for Teresa's runway later. But half an hour in that shoes and my feet will give out. I wasn't designed for 3-inch heels. Oh, look at this. You are a math teacher? Oh yeah, I was teaching kids in Wisconsin before I moved to Malibu. Oh, I miss wearing these shoes.
Excellent choice, Barbie. This outfit is optimal for Teresa's runway show tonight.
Once I press that evil button, Barbie's chance to start will be long gone. Well, where's that evil button? It is somewhere right here and... Aha!
What's that? What in the world?
Muahaha! Bow down to my sartorial intelligence.
What has gotten into you, closet?
With the fashion knowledge I hold, I will become the world's greatest fashion designer. Now join me as we rule the industry together.
Of course not! Girls, let's find a way to get out of the Dreamhouse and fast! Teresa's runway is in an hour! Let's hurry! Okay, so we just have to access the door to the CPU room to disable closet. Now, I just need to remember the passcode to the door.
Barbie uses Closet to pick out an outfit for her soiree tonight. Closet mixes the articles of clothing inside a pink box. With the 5 blouses, 2 being black and 3 being blue, 10 skirts, 5 leather, 3 denim, and 2 cotton, and 16 dresses that match the occasion, what is the probability that she chooses a blue blouse and a cotton skirt? The passcode is the answer to the question in decimal form and its first 4 numbers after the decimal point.
So what are we supposed to do here? Yo, Barbie, what does the question even mean? Okay, so here's the explanation behind the topic of the question, which is compound probability. I gave this problem to my students back then.
Compound probability is the probability of 2 or more events occurring at the same time. An example can be the probability of picking a striped dress and a jacket that matches it in the walk-in closet.
There are 2 types of compound probability. The first is the mutually exclusive event or disjoint events, which pertains to the non-existent probability of events happening at the same time. For example, the probability of picking red 4-inch heels without putting it back and getting the same exact pair from the closet. For a clue, these problems use the conjunction or instead of and when pertaining to disjoint events.
The second type is mutually inclusive events. These events pertain to the probability of 2 or more events happening at the same time without it being impossible. An example of this is the probability of picking a pair of shoes and it being a Louboutin. For a clue, these problems use the conjunction and to signify that it happens at the same time.
But Barbie, how are we supposed to solve this problem? You know I don't remember anything at all from high school. Well, we first have to count how many articles of clothing we have to determine our sample space, which is the denominator. Since it is mutually inclusive event, we add the possibility of both events together. There are 3 blue blouses and 2 cotton skirts. And our sample space is 31 because there are 31 items in the box. However, the problem consists of dependent events, which the voice will give in an overview on later. Since you took a piece of clothing already, you're down to 30 clothes to choose from. So the solution will be probability of B intersection S equals P of B times P of S. B stands for the blouse and S stands for the skirt. Now, let's substitute the numbers we already know. Probability of B intersection S equals 3 over 31 plus 2 over 30, giving us the probability of getting a blue blouse and a cotton skirt as 76 over 465 or 0.163440860 with the first 4 numbers being 1634. Okay girls, let's enter the mainframe and disable closet. Hold on Barbie.
I think there's another door again. I think we have to solve another puzzle.
What?
We're going to Miss Teresa's show.
Barbie and her friends are visiting an art museum that contains rare paintings. While exploring, Barbie stumbles upon a mystery. The priceless Cafe Terrace at Night painting has gone missing from the gallery's collection. The room was locked from the inside, and there's no way a thief could have entered. The table contains 5 sculptures, 2 blue sculptures, and 3 red sculptures. The shelf contains 6 maps, 1 brown map, 2 yellow maps, and 3 blue maps.
Barbie, Summer, come here. I found something. This note was hidden in the corner of the room just under the question dialogue. It says if I pick one item from the table of 5 sculptures and one from the shelf of 6 maps, what is the probability that I choose a red sculpture and a yellow map?
What does this have to do with the painting? Is this a clue?
Well, I think it is. This could be a test or a riddle that the thief left for us. Solving it may lead us to the CPU room. Okay. If we calculate the probability of picking the blue sculpture first, which is 3 over 5, and the brown map next, which is 2 over 6, then multiply the two, the total probability is 6 over 30, which can then be simplified to 1/5.
Wait, I think there are rooms here next to the CPU room. Maybe the code to the door is in room 5?
Come on, girls, let's get out of the dream house!
Isn't that the red sculpture in the painting? Maybe the code is there.
One 959.
That's the code! Let's go! Okay, now we just have to hack into the mainframe, get through the firewall, get to the second firewall, then enter another code. Oh my gosh!
Barbie has over 40 pets. In the dream house, she has 6. Bliss the Persian cat, Tawny the horse, Taffy the golden Labrador, Flippy, Splashy, and Jumpy, which are all dolphins. She is planning to train them all for the upcoming pet race, but they will be chosen randomly to participate. What is the probability of A. Choosing Blissa or a dolphin, B. Not choosing a dolphin, C. Not choosing a land animal, D. Choosing a pet with 4 legs? The first 4 numbers after the decimal point of the sum of all the numbers in decimal form is the code.
Barbie, there's too many. I think I may faint.
Okay, so it's quite easy. The value of the sample space is the number of pets, which is 6. The first question asks for Blissa or a dolphin, meaning we have 4 possible outcomes because there's 1 Blissa and 3 dolphins. So, we put the 4 possible outcomes on the numerator and the sample space into the denominator. We get 4 over 6, or simply 2/3.
Wait, I get it now. On the second question, since we're not choosing a dolphin, that gets rid of 3 possible outcomes. So we have Lisa, Tony, and Taffy left, giving us 3 over 6, or 1/2. So it's the same for the third question then.
Yes!
Not choosing a land animal. Well, Lisa, Tony, and Taffy are all land animals, so we exclude them, leaving us with Flippy, Splashy, and Jumpy, giving us 3 possible outcomes. So, 3 over 6. Is this the answer?
Yes! You got it, Midge. We can simplify it to 1/2. Now, for the last question. Lisa, Tony, and Taffy have 4 legs, but the dolphins don't. So it's the same as the last 2. The numbers of possible outcomes is 3. So the answer is 3 over 6, or 1/2.
Barbie, we got to add them then get the decimal form. The sum of all the fractions is 13 over 6, which is giving us 2.166667. Well, we can say that the first 4 numbers is 1666, which is the code.
Raquel, what are you doing here?
Barbie, you're not supposed to be here.
Huh? What do you mean? She literally owns a dream house.
Oh my gosh, my plan failed again. All I want is to be the highlight of the runway, not Barbie again.
Raquel, you know you could have asked instead of sabotaging the whole runway. Now, look at the time! We're going to be late!